Hello everyone. In this lesson we are gonna be talking about linear equations, what they are, how they work, and how we can turn them into matrices. So what is a linear equation? A linear equation is an equation where variables are raised to the power of 1. We cannot have any x to the power of 2, y to the power of 3, or square root of x, right? So no exponents. And it's important to emphasize we're only talking about variables. So let's take a look at some of the examples we have here. 5x plus 3y equals 15. As we can see, there's no exponents, so this one would be a linear equation, right? When it comes to the second equation, we can see there is x to the power of 2, which is not linear. So this one would not be a linear equation. The third problem looks kind of tricky because we see there is 2 to the power of 2. But as we said before, we're only talking about variables, right? It doesn't matter if there is 2 to the power of 2 to the 2 to the power of 3, it doesn't matter. It's still going to be a number, it's not a variable, and 2 to the power of 2 would be 4, which makes this a linear equation as well. Uh, Problem number 4 has a square root, which makes it nonlinear. Problem number 5, straightforward, x to the power of 2, y to the power of 3, doesn't work. What about the sixth one? This one looks a little bit tricky, but it's kind of the same as problem number 3. Square root of 16 will be 4, which makes it a linear equation. Now you might be wondering, why do we call those equations linear? To understand that, we need to look at a few graphs. Okay, I'm just gonna sketch it quickly. Okay, now let's look at these graphs. As we can see, x squared creates this parabola, right? It creates a curve, which is not linear. When it comes to the equation that doesn't have any exponents, it is a straight line, which makes it linear. This is what we're gonna be talking about in this course, right? Only linear equations. No curves. So now let's take a look at system of equations. I'm gonna erase this quickly. Okay, let's look at this system. Okay, to solve this system, we could start by isolating y. And then we're gonna solve for x. So this would be our answer. Okay, but what if the system is too complicated? Let's take a look at another example. So instead of solving this by hand, we can represent this system equation as augmented matrix. In order to do that, we have to start with square brackets like this, and then I'm just gonna do it a little bit lower. Okay, so we don't have to write x, y, z. I'm just gonna write it for the sake of the understanding. Uh, okay, and so all we have to do is we just have to write the coefficients, right? We're gonna start with coefficient of x. This would be 2, this would be 4, and this would be minus 6. Okay, let's take a look at the coefficients of y. This will be 3, this will be minus 1. If there is no coefficient, it's going to be minus 1. And then 2. And then it's going to be minus 1, 2, and 1. 5, 10, and minus 1. Okay, and this is what we call an augmented matrix. Let's take a look at another example. It's slightly more challenging. As we can see, we don't have some of the variables here. I'm just gonna rewrite it in a slightly different way, just so we have a better understanding of what's going on. Gonna start with 3x, and then we're gonna do plus 0y, 2z. Then we're gonna do 0x, okay. So as we can see, if we're missing a variable, there is a 0 instead of it. So now it's going to be way easier to represent it as an augmented matrix. We're just going to start with x, so it's going to be 3, it's going to be 0 and 1. And this is it. Thank you so much for watching, guys, and I'll see you in the next lesson.